You install a fresh app on a phone, sign in with an account that has never touched that device, nothing carried over, and the platform still treats it like it already knows what kind of device it is looking at. It knew before you typed anything. That is mobile device fingerprinting, and it runs much deeper than the browser version most people worry about. A web page only peeks through a browser window. A mobile app runs real code on the device, and it can ask the hardware questions a browser never can. This is what it asks, signal by signal, and why a real phone is so much harder to fake than a browser profile. I run real phone farms myself, actual handsets on real Singapore carrier SIMs, one account per device, so everything here comes from watching which signals actually get accounts flagged and which nobody checks. I will walk it the way the platform sees it, third person, because understanding the detection is the only honest way to run your own separate accounts cleanly. What a mobile fingerprint actually is. A mobile fingerprint is the same idea as the browser one, dozens of small device facts combined into one signature, but the surface is enormous by comparison. Inside an app, the platform is not limited to what a web page can read. It can query the operating system directly, read hardware identifiers, inspect sensors, list what else is installed, and even ask the device to vouch for how genuine it is. Every answer is another slice of entropy. Stacked together, they describe one specific handset far more precisely and far more stably than a browser can. Device identifiers. The first layer is the set of ideas a phone hands out. There is an advertising ID for ad targeting, and lower-level identifiers tied closer to the hardware and the account. Older systems leaned on the IMEI baked into the modem, though modern OS versions lock that down hard. The important part is not any single ID, it is that apps stitch several together with everything else. If two accounts appear on one device carrying the same cluster of identifiers, the platform does not need a login to know they share a phone, the OS build and its story. Then there is the exact software the phone runs, the build number, the model string, the manufacturer, the security patch level, the kernel version, the locale. Individually, these are common. Millions of phones share a model. But the precise combination of build, patch date, region, and configuration narrows the field fast, and it has to stay consistent. A device claiming one flagship model while reporting a screen, a sensor set, and a build that never shipped on it is describing a phone that does not exist. Sensors as a signal. This is where mobile pulls ahead of the browser completely. A real phone has an accelerometer, a gyroscope, a magnetometer, a light sensor, a proximity sensor, and they are always producing tiny, noisy, living readings. A phone sitting flat on a desk still registers faint motion and drift. An app watches those streams and tells a device a human is holding from one that reports perfectly still or nothing at all. Even the calibration quirks of one physical sensor unit can act like a serial number. Dead sensors are one of the loudest tells there is. Installed apps and the software environment. An app can also read the environment around it, which system apps are present, which stores are installed, what the software landscape looks like. A phone a real person uses accumulates a believable spread of apps and services over time. A device freshly wiped for every account, carrying almost nothing, or the same sparse loadout as 100 others hitting the platform, reads as provision rather than lived in. The pattern around the app is itself part of the fingerprint. Network and carrier hints. The phone also carries a network story, and it has to line up with the device story. The mobile IP, the carrier the device reports, whether the connection looks like a real cellular network or a data center dressed up as one. An account presenting as a mobile user in one country but exiting through a server on another continent is holding two halves that do not agree. The best setups keep the device on a real carrier connection so the network matches the phone, the same way a browser profile has to match its proxy. GPS and location hints. Location is another cross-check. A phone reports GPS coordinates, nearby networks, and the time zone, and the platform compares them against the IP and the language the device is set to. When the GPS, the network location, the time zone, and the account history all point at the same place, the story is coherent. When the location jumps continents between sessions, or the GPS says one country while everything else says another, that mismatch feeds the risk score. Faking a consistent location across every layer is much harder than editing one field. Platform attestation. Here is a signal with no real browser equivalent. Modern phones can be asked to cryptographically vouch for themselves. On Android, that is Play Integrity, which lets an app request a signed statement from Google about whether the device is a genuine certified phone, whether the OS looks unmodified, and whether the app binary is real. Because the answer is signed by hardware rather than self-reported by the app, it is extremely hard to forge from software alone. A device that fails attestation or only passes the weakest tier is quietly marked as not quite trustworthy. Why a phone is harder to spoof than a browser. Put those together and you see why the mobile layer is so much stickier. A browser exposes a thin slice of the machine, and every value it reports is, in the end, self-reported and editable. A phone exposes the whole device, backs many answers with hardware, and can be made to prove its own integrity through attestations. You are no longer just claiming to be a certain device, you are asked to demonstrate it in a way a signed chip either supports or does not. That is a far higher bar than swapping a user agent string. How emulators get flagged. This is why software emulators, a phone faked on ordinary computer hardware, struggle against a serious app. The sensors are missing or too perfect. The hardware identifiers look synthetic. The performance signature does not match a real handset. There are long lists of known emulator tells, from build properties to files that only exist in the emulated environment. And most decisively, an emulator cannot pass strong attestation because it is not a certified device and the platform will not sign that it is cheap and scalable, but it fails exactly where the important checks live. How rooted devices get flagged. Rooted or heavily modified phones sit in a similar bind. Rooting unlocks the device so its identifiers and behavior can be changed, which sounds useful, but the modification is itself detectable. Attestation notices the OS has been tampered with and drops to its weakest result or fails outright. Root hiding tools exist, and it is a genuine cat and mouse game, but you are now staying one step ahead of a check signed by the platform vendor. For someone just running their own separate accounts, that is a lot of fragile machinery to lean on. The identifier reset myth. People assume a factory reset makes a phone new again, and it partly does. It clears the advertising ID and wipes account data, but plenty of the fingerprint comes back untouched because the model, the sensors, the build lineage, and the hardware-backed identity are the same phone underneath. Resetting a device and loading a second account onto it is like clearing cookies on a laptop. The surface looks clean, while the deeper signals quietly link the two. A wipe changes what is stored, not what the hardware is. None of these values matters much alone. The platform is building a graph, connecting accounts through the signals they share. The same device identity, the same sensor quirks, the same network, the same attestation result under two logins pulls them together. One shared strong signal can associate a whole cluster of accounts at once. That is why a single reused phone can link a fleet that looked on the surface like unrelated strangers. The fingerprint is not there to identify one account, it is there to find the ones that secretly belong together. Consistency across the layers. The lesson from the browser world carries straight over. The device story, the network story, and the behavior all have to agree. A perfect handset on a contradictory network fails. A genuine device running an account that acts nothing like a real mobile user fails another way. The aim is not to strip the phone of every signal that is impossible and looks abnormal by itself. The aim is one coherent device that could plainly exist, telling the same story across hardware, network, and location, where genuine separate devices fit. So what actually holds up? For accounts that truly need the mobile layer, the honest answer is a real separate device per account. A genuine handset has real sensors, a real hardware identity, and passes attestation because it actually is a certified phone. It is not pretending to be anything. The cost is obvious. Real devices and SIM cards are the most expensive part of any stack, but for a valuable mobile account a browser cannot carry, a real device is the only story consistent down to the signed hardware, where cloud phones fit. Cloud phones are how that scales without a drawer full of handsets on your desk. The good ones are genuine physical phones in a rack, wired for remote control, so the device an app inspects is a real certified handset rather than an emulator hoping not to be checked. That is what clears the attestation and sensor checks an emulator fails. They earn their cost when a platform is app-only or leans hard on attestation and the browser profile cannot run the account. For everything that runs fine in a browser, there are more devices and more expense than the account needs. Isolation is still the rule, and the oldest rule does not change because the device got more sophisticated. One device, one identity. A single phone running 5 accounts hands the platform the same clean device match as one browser profile running 5 logins, and every signal above only makes that match more certain. Each account wants its own device, its own number, its own connection, sharing nothing with the others. The hardware got harder to fake, but stacking accounts onto one phone still throws away the whole point of having a genuine phone. The honest limit stays where it always is. None of this makes an account untouchable, and anyone promising that a certain phone or trick guarantees you never get flagged is selling a story, not a result. Attestation gets stronger, emulator detection improves, spoofing methods get caught, it is a moving target. What a genuine, well-isolated device buys you is that each account stops looking like the same fake machine wearing new names and starts looking like what it should be. One real phone with its own quiet, consistent identity. Everything after that still rides on the account behaving like a real person. I run this stack myself, real handsets on real Singapore carrier SIMs, one account per device, warmed slowly and kept on their own connections because I wanted the mobile layer to be genuine rather than an emulator crossing its fingers at the first attestation check. The full guides and tested pics are at multiaccountops.com with the whole breakdown of mobile fingerprinting signals, when a real device or a cloud phone is worth it, and honest reviews of the devices and services I run on live accounts. No affiliate guesswork. If you want to run your own separate accounts properly rather than quickly, that is where to start. Subscribe for more honest, tested multi-account ops. Next time, the account graph, how a single shared signal, one payment method, one recovery number, one reuse device can quietly link a whole fleet at once, and what it takes to keep those links from forming.